Understand in this picture presentation. Let's take now Nabi, Vijay, and Kausik. We are 3 users. We are trying to do some shopping. Let's take from Amazon or a Flipkart. Okay, through their online web application. Ultimately, the data is going. Is my voice is audible?
Yes, yes.
Yes. Right. Okay. So now the data is going to whatever you do the transaction, right? Ultimately, it is going to store in a database. Let's take that we used to call OLTP, Online Transaction Processing DB. The database can be SQL Server, Oracle, or Teradata, some database. Okay. All the online transactions, whatever happening through this web application by customers, it is storing on the OLTP database. Now let's take in this scenario, we will take Nikita. Let's take Nikita is Amazon owner. Let's take Nikita is Amazon owner. She want to know how each product, whether we are making any profit or it is going on loss. Each branch wise, in which branch is doing good, which branch is not doing good. For decision making, okay, that is what our requirement as a executives, as a owner of the Amazon. But where the transaction is there, it is there in OLTP database, right? Now Nikita can recruit Priyanka as a SQL or report developer. She can start directly querying on a database, the OLTP database, which is majorly designed to serve for end users, the customers. Like take in this case, Nabi, Vijay, and Kausik. We are all the end users. We are trying to purchase, and it is trying to load and giving response. What is the status? Whether it is a in progress, delivered, right? All those it is happening. This is the database. Now, for analytical purpose or decision making purpose, Nikita is trying to, or Priyanka is trying to query on a database which is serving to the end users. What will happen? Is there any problem if you try to query on a database which is majorly serving for this end users? Nabi, is there any problem the database is going to face if you try to do big analytical queries for Nikita purpose, for analytical purpose, but this design is to basically to serve to the customers, end users. Is there any problem you are expecting if you try to do that big queries on a database?
I guess so.
What might be the problem?
The queries might take long time and that would result in like user interaction.
Yeah. When you try to write a big queries for analytical purpose, obviously, as you mentioned, this website is going to slow down because this OLTP is not designed for analytical purpose. It is trying basically for users. Suddenly, now Nabi is trying to query, right? Which the performance will be go down, and ultimately this website is going to, when you're placing orders, like Kausik is placing orders, it is very slow. So as per industry standards, if the website is not responding in less than 5 seconds, then if there is any alternative, people will move on, right? It is not good to do something which is doing good and making, there is another problem you are introducing, right? Not good, number one. Number two, the database, the data might be scattered in different places. For example, Amazon might have a sales rep. They're using a Salesforce data. For interacting to the customers, they are using a CRM system. They're using a CRM system called Salesforce. All the sales reps which are interacting with the customers, that information for business purpose, right? The insurance or sales reps will go and interact with the companies, right? So that data is in Salesforce. Now, original transactions are there in this database. The sales rep interaction with the customers are here. Now let's take again here. Nikita is a CEO of Amazon. She want how many through Salesforce, how many customers that sales rep is interacted with, that how many transactions we got. Now let's take this is a this is a SQL server. This is let's take it is a backend Salesforce. Now you cannot write a query, or Priyanka cannot write a query to two database with like how you join two tables in a database, right? You need to write a big lines of code. Now that is number two problem. Number one is you are trying to query a database which is serving for the end users, wherein you are facing some performance issues, not recommended. Number two, the data which is required for reporting is scattered in different places in different formats. To gather, to join, you might need to write a lengthy lines of code to make it a proper reporting, right? That's also not a good practice. Number three, for executives, for example, in this case, Priyanka, she don't require each and every transaction to do analysis, right? She want overall that branch, how the sales are going, or that product, how much sales, how the sales are trend is going on. She wants some kind of summary data, not a very low level data. Again, that data is not there. Every other detail it is there here, very low level. For decision making, it is not required. These are the three main reasons why we go and build a data warehouse slash BI system. Data warehouse slash BI system, business intelligence system. Okay. So in order to do that one, in the olden days, we used to write some programs using Java or Visual Basic, COBOL, .NET, right? These are the big programs we used to write to do nightly. So again, now Nabi can question me. You are telling don't query. If you try to query this database, the performance will down, right? Yes, you are correct. But we try to extract the data which is required for business analytics or for reporting or decision making. We extract through night time. Generally, night time nobody will purchase, right? The system will be idle. During that time, we will extract, transform, and load using some programming into a database. This is also a database, but it's a big in nature. Now again, the writing lengthy lines of code, it is again making very difficult for the programmers. So then this software system, I mean, it's a product companies, they started, why cannot we can build an ETL tool? You just tell this is a source table and small like Excel kind of expression, and try to tell the destination where it has to load. ETL, extract, transform, and load. So in that classification, Informatica is the number one tool which is having capability to extract data from different sources, transform and load into a destination database. Now Informatica is making lot of, Informatica is an ETL tool from an Informatica company. Again, data stays from IBM, right? BODS, Business Object Data Services from SAP, Pentaho. All right, so many ETL tools are there in the market. Like in RDBMS, you have SQL Server, Oracle, Teradata, DB2, right? So many are there. Similarly, in ETL, the number one is Informatica. Informatica is a famous ETL tool which is having capability to extract data from different sources, transform and load into destination. That's what we are used to call data warehouse. Now Informatica, from Informatica is making a lot of money. Now Microsoft is not a charity company, right? Let's take Kaushik. You are a product company. You are, let's take, you developed already some operating system. Now suddenly Priyanka started Informatica. She is earning so much money. Now in a competition, as a product developer, you will not keep quiet. Okay, let Priyanka earn the money, right? It's a competition world, right? So Microsoft, they have a built-in component called DTS, Data Transmission Services, DTS component inside SQL server itself, wherein it is having capability to extract, transform, and load information data. SQL server from Microsoft, they used to tell, okay, we are also having ETL component. But whatever the capabilities, characteristics, and capacities which are there by Informatica, that beauty of the tool, Informatica tool, we don't have that in DTS component as part of SQL Server. Okay. So how many times people will tell if it is not equal competitor of Informatica? So people are not liking actually the DTS component after seeing Informatica. Now Microsoft decided, okay, it is not going to work. Let's build our own enterprise ETL tool called SSIS, SQL Server Integration Services, as an ETL tool from Microsoft under umbrella called MSBI, Microsoft Business Intelligence Team. One more thing. Tomorrow, if you go and work on data engineering, Azure data engineering, there might be a probability where you might work on SSIS also. It's a very easy tool. I'll tell you how to learn. I might go and teach 3-4 classes which is required. But SSIS is an on-prem ETL tool which is having capability to extract data from different sources, transform and load. Number one. Number two, from MSBA family, they also introduced reporting tool called SSRS, SQL Server Reporting Services, and SSAS, a cube, SSA SQL Server Analysis Services. Combinedly, they released the tool in 2005 with the name called MSBA, Microsoft Business Intelligence. From 2005 to 2017, almost 12 to 13 years, this MSBA ruled in BA. Almost 30 to 40% of the projects are in MSBA, I mean to say DWBA projects, okay? So easy to learn, easy to get a job, and easy to work. Three easies, right? So that was the background history of a MSBA. So now from Microsoft, we are using SSIS tool to extract, transform, and load. Based upon, let's take, if all your projects are in SAP, they might go and use BODS to do their ETL work. If let's take, there are components already in IBM, they might go for use data stage. They take they want to big loads, then they might go for Informatica. So based upon already company what they're using and based upon the requirements, they will choose the required ETL tool. There is no mandatory that you have to go for SSIS only. You can go for anything based upon their solution architect, the company, budget, all they will decide which tool they have to go. Now recently we have a Talent. Talent is again one more ETL tool, right? Matillion, that's another ETL tool. Whatever, tomorrow it can be 100 ETL tools, but the concept is same. Extract, transform, and load. Extract the data from different sources, transform and load. Okay, that is what. Then now data is there, right? Now data, required data using during night time. That's what we used to call batch processing. During night time, we extract data from different sources, transform and load. But now Priyanka is the CEO of Amazon, right? She is here. Priyanka here, big people, right? So data is there in tabular format. As a CEO, what she will understand? No, right? Either you go and process the data using cubes, or you directly recruit one developer. Now maybe Nikita is recruited for reporting. Now Nikita tried to do the development of different reports for CEOs or D level or C level. We used to call directors and chief executives. What are the big top executives, right? For that, they will develop, the developers will develop based upon the business requirement, different reports. Either you can build a cubes on top of the report, or directly from the data warehouse you develop a reports, so that the decision making, they will slice and dice, or they will see the data and take a proper decision. So data warehouse / BI is a system in which we gather the required information and present the report. Okay. So any doubt on this team? where you are going to fit. You might go and fit as just a developer, SQL developer. That is one job. If you are strong on SQL, there are so many openings on SQL Server developer. No, if you are okay, then you can use a SSIS or our ADF, right, which I am going to teach. ETL developers, or you can become a report developer. You might learn a Power BI or Tableau, right? One, if you learn one, other one will be easy. So these are the three different roles or jobs which you might work based upon your needs, right? Based upon the company needs, not your needs. So any doubt, team, where you are going to fit? What is your roles and responsibilities or this architecture of data warehouse?
No.
Anybody? Yeah, thanks. Okay.
No, sir.
Okay, now we will also go some very good theory concept. I already forwarded this PPTs for you guys. Just go through that one. It is very, very important to understand why we are doing what we are going to do actually, right? Function FI. Now this is what I try to tell, where we will have OLTP online transaction. We are going to use ETL tools and put the data into data warehouse. Data warehouse is also one more database like SQL Server only, but you might get the data from different sources. But ultimately, data warehouse is a database only, nothing more than that. Then cubes and reports and executives will come and see, take a decision. So, like in all other fields, there used to be fathers of, right? Like the father of computer is Charles Babbage, the father of civil engineering somebody, right? So for every domain or every field, there will be some fathers or a gurus, right? Now in the data warehouse, also we have a guru, the father. Bill Inman is a father of data warehouse. So what he used to tell, he has given 4 definitions. Data warehouse is a subject-oriented, non-volatile, time-variant, and integrated. So basically, we are all integrated database to keep historical and data along with current data in a summarized. What the purpose is to analyze and take a strategic decision making. So basically, we all do this for to take a better decision so that organization can run in a smoother fashion. Okay, that's what the data warehouse. So we'll try to understand each and every terminology, right? Integrated. Integrated means, if you look at my previous picture, so we are integrated data from different sources. We extracted data from different sources and kept in one single format. That is a database, right? That's what we used to call integrated. Number 2, it's a subject oriented. While extracting and loading the data into data warehouse, we segregate the data into subjects, meaning that sales database, sales or HR data mart, or finance. So we are going to segregate based upon their modules or subjects or area. That's what we call it. Like in our study, we have math, physics, chemistry, right? In the data warehouse we used to call subjects, meaning that sales database, HRDB, finance, payroll, right? There are all different subjects. Now, non-volatile. So if you look at our architecture, once you extract and load, then there might be very less opportunity or less probability wherein you are going to delete or update the data. You extract, select, and you load into data warehouse. So the probability of updating and deleting is very, very rare, very, very rare. So I can say only 2 to 5% of the cases you will might go for updations and deletes. Non-volatile. It's a non-volatile means it is a data warehouse is history. It is a fact. It is happened. Now the probability of updating is very, very rare. That's what they used to call non-volatile. But whereas in OLTP, it is not a non-volatile, because now let's take Kaushik can place an order in Amazon. After one day, he can cancel. So what will happen here? The record will update, right? With the status cancel, right? It is updating. But in the data warehouse, you are already extracting the fact data, which is already happened. It's a history, right? That's what we used to call non-volatile. Time variant, basically, we always do analysis with a trend base, right? So what happened last year? What happened previous year? How the trend is going on? So our analysis is going to do with respect to time. That's what they used to call time variant. Subject oriented, non-volatile, time variant, and integrated. All we do to keep historical, and in data warehouse we'll have old data plus current data in an aggregated format. So I already told, right, we don't require very low level detail, aggregated. We do this to analyze and take a proper decision. Okay, this is what the definition given by Bill Inman, is a father of data warehouse. After that, we have Ralph Kimball. He is also come out with a different approach. So Bill Inman, in the next model, next slides, I'll tell you. Remember, there are two people in data warehouse, Bill Inman and Ralph Kimball. Bill Inman is a father of data warehouse. Later, we got a Ralph Kimball who introduced dimension modeling. Okay, so we'll discuss on that one. Any doubt on this thing in this slide? Good. Okay.
A quick question.
Yes, please.
So, so with that help of ETL process, we are pulling the data from the database to the data warehouse, correct?
Yes.
So, so in this slide, in this slide, so you mentioned that OLTP database from here. It's like, so another example where you mentioned that Salesforce CRM, that database is also there, right? So, so this ETL process brings data from OLTP as well as Salesforce or any other database.
That's what, if you
everything
look at my
together.
definition, OLTP, the ETL tool, is having capability to extract the data from different sources. Means
Okay.
it can be a database, it can be a file, it can be a Salesforce, it can be SharePoint. So 100 plus sources are there.
So,
Nabi right? Yeah.
So, for example, if there are like 3 database from where it's taking the data, but it can happen that all this database can have different query language, right? Or
Okay.
it has to be same query language.
No. It can be different. For example, as I said, Salesforce, they used to use a query language SOQL. Salesforce Object Query Language, SOQL. So if you try to extract SharePoint, it is a list actually, like Excel. So they will use the native language to extract. So the ETL tools, maybe, once you use that source component, they will build into built-in components. Once you drag and drop, it will try to give a corresponding native query language for you.
Okay.
The tools will have that built-in components actually.
Okay.
Right? Yeah.
Okay, got it.
Any other doubt, team? Okay. Now, what is a data warehouse is not? So data warehouse is not a copy of, because as Nabi asked, you just pull everything, then it becomes data warehouse. No. Data warehouse is not a copy of source database with a name prefix with TW. Let's say there is a sales OLTP in OLTP. You just take a backup and restore and just prefix with a DW. No, that is not a data warehouse. Right? For Priyanka, now let's take Priyanka, let it be owner for you, Amazon. Okay. So now Priyanka don't want entire garbage to bring into data warehouse and take a decision. No. So if you remember, I told it's aggregated, summarized, only required data. For example, let's take customer. You'll have first name, last name, middle name, gender, your surname, date of birth. So many will be there in a customer table. For CEO, you don't require what is his first name or middle name. At a high level you want, right? So it is not a copy and restore database, is not a data warehouse. It is not a copy of multiple tables again. As I said, just dump as it is all the tables is also no. It is not a dumping ground, right? Just dump everything from the source. For example, somebody who worked on Salesforce, they might see in a customer object, There used to be 500 fields used to be there. So which is not required for analytical purpose. So it's not a dumping ad, only we will retrieve query the data which is required for analytical. There is a big science involved in the data warehouse proper design. So if you really having experience, that's a big study we do before we build the dimension and fact tables. I'll tell you what is dimension. So this is not a data warehouse. Then what is a data warehouse, or why we go for data warehouse? Reduce stress on production system. This is the first point I told why we go for data warehouse. Because if you try to run a queries on the production system, which is serving for end users, obviously the performance will be go down, and the end customers will face a problem, performance issue. So what we are doing to avoid that one, we are extracting the transformer load during night time, which generally the user base is very low to purchase. So that your data is segregated into data warehouse. From there you do your analysis. That's the number one. Number two, so I told, right, we will extract and load. After that, we only query. So basically data warehouse is majorly designed to query. I mean, say you might do different reporting. Reporting means queries, right? Now integrate many sources of data. One is OLTP, one is Salesforce, one is SharePoint. You are integrating data into one source. The one source is a database. The database can be anything but one. I mean, say it's a SQL. Keep historical records online. Basically, your data warehouse will have old data and current data, so that both you can query for your reporting purpose. Restructure, rename tables and fields. So let's take your system. The OLTP system is designed 30 years back. Now, for example, they given, I'll tell you one of my real-time example. I came to US for Phoenix. I want to design some data warehouse. In their OLTP, one of the table name is SR names. So we are not able to, by seeing the table name, for example, if you have a table name called customer, by seeing the table name, we know it's a customer data. If it's an order, we know it's order data. If it's a department, right? But if you, by seeing the SR names, the table name, what you got? Nothing. We are not able to interpret by seeing the table name. But the system is designed 20-30 years back. Now, then after querying and analyzing the data, we came to know that this is a customer data. Basically, SR names. Why they prefix SR? SR is a company name. Okay, some SR form I forgot actually. SR is a company name. Names is customer names. So it should be the customer detail. That should be the table name properly. They might have designed in OLTP. Now let's take, since they done a mistake, we don't want to bring that same garbage while we are designing the data warehouse tables in the data warehouse system. So what we given when we design the table for SR names, we given a table name dim customer. That is, so by seeing the table name, you can think that okay, this table will contain the customer information. So we might go and model the data with the proper names. We might not again put the same name as SR names. No. So that's what the point of this one. Protects again source system upgrades. For example, OLTP, there is some upgrades are happening. In our data warehouse system is different environment and different database. We don't bother about that one. And again, use master data management. In the olden days, even nowadays also, what is happening is, for example, in HR system, my name is Vijay Kumar Guntumadugu. In payroll system, my name is Vijay Kumar G. In my project, the Kumar Vijaya G, right? So the data used to be in different systems, same person name is different in different places. So to avoid that one, nowadays they are maintaining a MDM, master data management, a central repository. Each and every subsystem, they have to access their master data from single central system. Okay, so they cannot build their own employees and shortcut, nothing required. So that is used to give a lot of problems in reporting. The consolidation is not happening properly because of the company is not maintaining MDM, master data. So this is also a separate job role, wherein apart from ETL developer, report developer, SQL developer, there is a master data management, MDM developers are also there, but very few jobs are there in the MDM side. Now, no IT involvement, then it is not a, I mean, say 100% correct. So basically this point we are trying to kept here is, once you pull the data from different Salesforce, Oracle, SharePoint, because now the data is in single database, so you might require little knowledge to query. The SQL knowledge is enough to start your reporting. So that's the meaning of this one. Improves data quality and plug holes in source system. For example, I told, right, if there are some issues in the source system, since you are building a new data warehouse, what are the problems it falls which they used to face in your data warehouse system, you can fix those actually. One version of truth, basically now in OLTP, you are extracting data from OLTP, one query language, as Nabi said, Salesforce, SOQL, it's a different language, SharePoint is a list, it's a different, but using ETL, you got everything into SQL, right? One version of truth. Easy to create, BA solution on top. Once it is there in database, you can build a different analytical reports in a easy way. Okay, so that is why we go for data warehouse actually. What is not a data warehouse and why we go for data warehouse? Any doubt, team, on this one? Team,
No.
terminal is very important. Already, anyhow, recording I'll give. Already I given a presentation, I shared already. If somebody, because I given to the whole team only, maybe if somebody please ping me if somebody not received that PPTs, I'll send again. Okay, so if you no doubt, then in interview they will ask what is the difference between OLTP and the data warehouse. So OLTP majorly end users, right? Like bank, when you go per bank, clerical users will be there. They are the operators there. Verification and values. The number of users, for example, Chase Bank, how many customers will be there? It will be million or billions, right? But executives, how many? Chase, it will be few. Like it will be thousands, not more than that. I mean, say the owners or CEOs or executive directors and all. But number of customers will be more. Generally, it used to be 95 is to 5. Okay, if you have 1,000 customers, then there will be 5 people who can, from the operating, from the decision making side, there will be 5%. Let's take 1 lakh customers are there. Generally, you might have 1,000 people to maintain 1,000 or 500, something like that. Okay, so that is what the ratio. Concurrent is obviously very high. For example, Amazon, how many end users will be there? It will be millions or billions. How many owners or executives or decision makers? It will be like a lakhs or thousands. Session duration very short. Let's take if you go to ATM, if you keep your ATM card, it will not going to, you will not spend 5 hours or 2. It has to be very quick, right? But in OLTP, sorry, in OLAP, decision making, the queries might take sometimes minutes also, right? So it might be the session is going to be very long. Database, small to medium, here very large, because you are keeping not only current data, you are keeping historical data also. Data life, very short. For example, now let's take the transaction. Let's take Amazon, Walmart. They are not going to keep the data in the transaction more than 1 year. They are going to purge or archive into different systems. Because if they keep the historical data in the main system, the performance will be go down. That's what they used to tell. If you want to return an item, they might keep some duration. You cannot go and return your item after 2 years, right? Like if you go Costco and all, there might be some time limit, right? So database scope, one organization and multiple organization. Now Nabi can question, okay, if you are building a data warehouse for Amazon or some XYZ system, then what is the concept you are telling multiple organization? So again, let me take one of the example. I used to work for container selling and rental company. A container selling and rental company. For their marketing, okay. Now, if you go on Google something, yeah, I need a 5 containers. So it will give you different companies who is providing the containers like rental or sales, right? So now they want that who searched this that user information by this XYG company, right? Who is giving rental for containers? How they will get the data? You are, let's take our Nakita is searched in Google that I want 5 containers. Now it is given different companies who is providing. How this XYZ company know that information, somebody looked my information? Any idea? Any idea, team? How X5G company knows somebody tried and searched my information or my container or per container requirement? How that XYZ company know from Google? Kausik, maybe.
I think they'll pay Google to get their IP address or something.
Excellent. So yeah, now very good. Now if you go on Google, when you try to set up a Google Gmail account, there might be some agreement, right? We might share your search information, right? So, or if you try to YouTube, right? If you try to search also, they will tell some recommendation. So there also they will tell we'll share your data, but we don't read all those conditions. We'll check yes, 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 and our Gmail is ready. So there might be clearly there is an indication that we will share your data what you are browsing. So some 5 years back in Google they told you just send, no need of your profile, you send your Gmail address, we know what is what we know entire history about the Kausik, right? So what you are searching, right, what you are browsing, all they know. That much capture information they are capturing from us, right? So now the data is sharing across the organization. So for example, in this case, for my marketing, I am using, so as Kausik said, XYZ company is paying money to Google. They give me every day some feed, okay, who are all and their information. So Google will have our email address, our phone number, everything. Now this XYZ company will call the people, let's take in this case, Nikita searched for 5 containers. They will call, ma'am, you searched for containers. We will provide this. Are you good? And now Nikita can tell, okay, later you come or something. I need what was right? So meaning that the data is sharing across the companies now. Okay. In this case, I will use through the Google. Now the for analytical purpose, okay, we are going to store the Google feed, and how much transaction we got through this Google feed also we will do analysis. Okay, if let's take somebody, if you try to book some institute for training, they will tell you whether you came for referral or you through our website or through YouTube, my demo videos, how you came, right? So let's take nobody is coming from Google, then I don't require that Google feed, right? I might go for YouTube demos, right? So those also meaning that now information is shared across the organization. Response time, it should be very quick, not a factor. Let's take again, let's take Kausik, you kept a hotel, you are the hotel owner. Now let's take Nabi, and you also order dosa. So for Nabi, you have to give very quick, right? Because he's a customer. Now you are a decision maker, right? Or even after 2 hours, dosa comes also, you have to keep on quiet and eat, right? So not a factor. Your query is you are running for your decision making. Even it coming 1 or little more time also, it's okay. That's the meaning of response time. Data model, already in the initial class, people design the table, right? That used to call data model, entity relationship, or data modeling. Same we will do, but with a table called dimension fact table. That model we call as a dimension data model. We also do that as well, actually. Normalization is highly normalized. Data warehouse is a denormalized. So there is a concept called star schema, snowflake schema. We will tell you. And the data warehouse, the tables are going to be more of denormalized. So even if it's a redundancy, it's okay, but you might get a good performance because the data is huge. Okay, we will compromise in the storage redundancy side. Security level, highest level, because the system is exposing to outside, right? You are placing orders from your burner, it should be very high. Now the data warehouse generally you will access within the organization, the data within the on-premise network. So generally it is not that much security required. Event type, it is a manipulation oriented. You will insert, update or delete. It's all DML oriented. So data warehouse is a query oriented. Availability 24/7 means, let's take if ICICI claims that you can perform your online transaction or transfer money from 8 a.m. to 8 p.m., then it should be most 99.99% it should be available. That's the meaning of always. On demand, it is not a mandate. Sometimes let's take server down. Let's take our Nikita is a owner. She can do an analysis little later also. Not a problem. Because it's our organization. We need to compromise there. Summary level, as I said, it is every detail it will have. And the summarize, it will have aggregated data. Okay. Any doubt, team, here? What is the difference actually?
No.
Okay. So definition, again, data mart. Data mart is a subset of data warehouse. So data warehouse is nothing but it will contain all the enterprise data warehouse, EDW they used to call enterprise. So it will have all the data, but data mart is a subset. I told, right? You will have a sales data, you have HR data, personal banking. So you will have a subset of data. So now here there are two types of data marts: independent data mart or dependent data mart. So what these people are telling, this is the Inman methodology. So Inman, what is to tell is to tell bottom-up approach. So no, sorry, this is a Kimball approach. So what in this case they will tell is, okay, let's take your $10,000. Now this is a Kimball approach, bottom-up approach. Now you build a sales mart, sales data mart. After that, you have 10 more lakhs, 10 more $10,000. Next quarter, you build a say HR, and now you have one more $10,000 you build. So what these people are telling, incremental way of building, and finally you make is a full data warehouse. So it's like a step-by-step approach. That's what Ralph Kimball used to tell, bottom-up approach. So ultimately we are going to keep a EW, but step-by-step approach. It's a, I mean, say easy approach. Now what this guy in Bill Inman used to tell is, if you have more money, if you have a time, money and time, then even though it takes more time, you build a proper full data warehouse, enterprise data warehouse, and after that you make it small data marts. You just segregate the data based upon requirement. So this we are not following nowadays because we are all going on Scrum methodology, right? We are building mostly this one. Okay. So no, I want to build entire data warehouse, then I want to allow my users go for this as well. There is no hard and fast tool. You have to go for bottom up or top down approach. It depends upon organization. Now there are different architectures wherein we generally follow this approach. Okay, you will have a sources, ETL, and again ETL, staging, and ETL, and data warehouse or data marts. Generally, we'll follow this approach. Again, there is no hard and fast tool. Some people, they will go for OLTP, different sources, and ODS, operational data store. this approach also people will go. So why ODS we require operational? Sometimes we might use this data warehouse system in between for operational purpose. For example, again, one of the real-time requirement is in one of the project wherein they used to generate commissions for sales reps. You know, right? Sales reps used to get a fixed money. They take $2,000. After that, they will have how much sales. For example, each sale they will have some $200 actually. Now the data and plus how many customers they interacted. Sometimes they might interact the customers. Initially, there won't be any business. So three components involved. One is a fixed salary. Second one is through that how much sales we got. Again, for sale, let's take a very simple example. Let's take Kausik is a sales rep. If you sell one bike, you will get a $500. Fixed salary is 2,000. Now, during this process, he might have called 100 customers. 100 customers into $10, he will get 1,000. 2,000 plus let's take he sold 4 bikes. 2,000 plus 4,000 plus he might have interacted 100 customers into 10,000. Totally 5,000. How many customers he interacted? The data is there in Salesforce. And how many sales he got there in a OLTP, right? So now fixed component is there in a payroll. So data is there in different places. So using ETL, we extracted the three information into ODS. After doing a payroll of that commission generation, then we push the same data for data warehouse purpose. So this is one of the real-time requirement where we go for ODS in between. So nowadays we are a very rare combination, but there is this also one more architecture. One is sources, ETL, stage, then data warehouse. Other one is OLTP, ODS, then data warehouse. And look at this one wherein you have different sources, warehouse, then directly from the data warehouse, different reporting can happen. The executives can do their reporting, analysis, and data mining. So I told, right, this is the majorly we go use sources, staging, data warehouse, and users. This is a majority of the people we are using this architecture. Sources, ETL, staging, ETL, warehouse, and reporting.
What is a staging area, staging database?
Staging is a temporary, like it's a bus stage. Yeah. So I'll tell you, okay, so that you remember very easily. Let's take I want to travel from Bangalore to Delhi. For example, very simple. So from my house, I will not get a flight, right, Nabi? So first I need to go for some bus stage, right? Let's take BMTC bus stage, wherein I can get a airport bus. So you are not going to stage bus stage in bus station or bus stage, right? Permanently, it's a temporary. So, okay, let me go into this architecture. Okay, now let's take you. Okay, it's a temporary. First of all, staging is a temporary database. So you going to extract the data from here and keep here, and you are extracting data from this and keeping here. For example, let's take I have a data of sales step and the transaction, right, amount and how many quantity is sold. That data here it is there. Let's take Salesforce. How many customers he interacted here it is there. Now my requirement, Nabi, I want the sales rep, total amount the transaction, how many count, how many customers he interacted, the Salesforce data here it is there. The OLTP, the transaction data. So what I can do, I'll bring this table here, and I can join those people based upon a common key called sales rep and push the data into data warehouse, delete these staging tables. It's a temporary truncate, right? That's the purpose of staging database. Staging is a temporary.
So for each query, you will have a staging database and then delete it and then again create another one for another.
Yeah. Yes,
okay.
You're correct.
Okay.
Yeah, these are the different architectures which you might come across in your projects. Okay, so next is Okay, before I go, any doubt team on this slide, I can repeat. Very, very important concept. So if you are claiming you are a data warehouse developer, ETL developer, or a BA developer, apart from this slide, you also go for one key data. There is a one key data. In that there is a link called data warehouse. There is a, that's, you go through that link as well. So you have different terminologies. Same thing. What is data warehouse? ETL reporting you will have. So anyhow, I'll cover this dimensional modeling under. Let's go to this slide. This so here you will tell same concept. You will tell it is a subject oriented, integrated, time variant, non-volatile. It's same, but for the reference purpose, I'm trying to tell you to go through that this link as well for a concept. So terminology is very, very important thing, because see, tool you can learn, and there are 100 ETL tools, but the concept is very important. Let me put in the chat window. So we'll revisit this concept again. So what is data modeling? Basically, it's a process of designing a tables, right? You already designed, for example, Kaushik, you design some database for what? For library. Some people design for dominoes. So that process we used to call data modeling at a high level. So there are two types of modeling. OLTP, whatever you guys done, that one is a OLTP. And now in the data warehouse, we used to have a different same methodology, but here we use a different terminology, but it's also tables, but different terminology we use. So that we call as a dimension data modeling. Okay. So there are three. One is ER data modeling that you guys already done. Second one is for data warehouse, we use a dimension, and one more is data vault. Data vault we are not using much, but at a high level we have three. So we will majorly focus on dimension modeling. That's what our core, right? Data warehouse side. Now, if it is any model, whether it's a ER or a dimension or data vault, you have to follow these three: conceptual, logical, and physical. What is conceptual? Conceptual means, for example, Kaushik, you got a requirement, one project. Let's take same case. You want to do Domino's pizza. Is they asked you to, Kaushik, we gave a project for you to make our system online Domino's online ordering system. And you don't know business, right, Kaushik? For example, no, of course, you know pizza, but assume that you don't know about what are the different products they will sell, what are the items, how the business, right? So you go and interact, you'll ask the Domino's technical person or the person who gave business to you, hey, can you introduce me to the people who knows this business? Okay. So okay, who knows the business, then they will explain, Kaushik, saying that okay, we will basically have a different categories, and again we will sell pizzas, we'll sell some chicken item, right? Not only now pizza, people are Domino's not only selling pizzas, they're selling other items, right? And again we will have veg, non-veg. So they will explain the concept, and high level the entities. Okay, you will have a orders, you will have a customer, you will have products, you will have category, subcategory, employees, branches. At a high level, they will tell the conceptual, what are the different entities and attributes, what are the column. For example, in a customer entity, you might have first name, last name, middle name, their date of birth, username, phone number. At high level, they will explain those different entities is nothing but tables in our technical terminology, but business people, they might not understand what is a table, primary key and all. So at a business terminology, they used to tell at a concept level. So that either you note down in a paper or in a Word or Excel, and after that you will design logical model. Okay, by this time you know what are the different entities and columns are there. You will come to the office and are in their premises. You will try to put either in the Excel, or there are different modeling tools. Very a good job is there. There is a lot of demand on this and I paid salary. Data modelers. There is a job role called data modelers, like how ETL developers, report developers, right? Similarly, there is a data modelers, right? Dimension modelers. So either you use that, there are famous ETL tools, modeling tools called Irwin, entity relationship for Windows from CA company, or MS Visio from Microsoft. Right, Toad. There are different tools are available to do that modeling. It's nothing but maybe you guys created in Excel, right? The table and different relationship, primary key, foreign key. That's only the modeling, but they're using the tool to represent in a different. For example, if you have 50 tables, right, it is very hard to maintain in Excel. Okay, so that way they were going for tools actually, but the concept is same. Whether it's you do in Excel, you do in Irwin, right? Entity relationship for Windows, same, but they are using a different tool actually. Okay, there you will design, and finally you are going to create a target to need to create the table in SQL Server or in a Oracle. So that is we call as a physical model. So here you will see directly the tables in the form of primary key, foreign key, the physical tables in the database. Okay, the target script that used to call as a physical data model. Okay, any doubt, team? At least the whole team who spend some time, half an hour on the what are the to create tables in Excel and all that. Any doubt there?
No.
Okay. So same concept I kept in a Word format. So in conceptual model, who are all going to involve? So basically the data modeler, obviously let's take Kaushik is a data modeler, and the business analyst are the people who, so they combinedly they will study the system, come out with the conceptual model. So that is what logical model here also business analyst with data modelers or SMEs will subject matter experts. Here also, because once our Kaushik design, then we'll validate with the business analyst. But physical is more of technical. So here there might not much involved of business users. It is more of a technical where you are trying to create a tables and relationship, primary keys, foreign keys, all those business rules and all. Here it's a pure technical. So right. So dimension modeling here in the OLTP system, generally we'll have a table names like product master, customer, orders, branch, DEPT. These are the different tables we will see. For example, in this scenario, orders is a transaction table. Branch is a master table. Employee is a master table. DEPT is a master table, right? Attendance, for example, that's a transaction table. Okay, so basically we will see there are transaction and master tables or a parent or child table. In OLTP system or ER data ER modeling, we used to have that terminology, master and child or a parent or transaction table and master table. When it comes to data warehouse, they're changing the terminology. It's also tables, but the terminology is going to change. How? Now, for example, it is a, let's take a department or a product. Now, product OLTP system is a product. When you try to design the table to load the product data into data warehouse, you are going to create the table as DIM product, DIM product. Same thing, for example, DIM country. Now we are prefixing for all the master table in data warehouse side as a dim dimension, right? And orders table, we are trying to give, let's take orders in OLTP. When it comes to data warehouse side, we are prefixing with the fact orders. Now Nabi can question me, what is fact? Why it is? Even in data, in OLTP also orders, how does it become a fact? Now, when I am there in Accenture, almost 12 years back, one person came to teach this concept of data warehouse. We asked the same way, what is the need of fact? You can be just fact, you just can be, it can be orders only. Now, if you look at our data warehouse definition, it is containing historical data. It is a fact, it is happened. Nobody can change, right? It's a fact. Now let's take Kausik purchased 2 years back so and so item and so much quantity, and this is the price. It has happened, and you extracted, loaded, no update. It's a fact. It has happened. It's history. That's what we are trying to give. It's a fact table, and we are going to analyze the data in a x-axis, y-axis. For example, I can have market in a one dimension, product in another dimension, and with the combination, what is the sales? This is a 2-dimension. Now with the time, 3-dimensional, right? So I can go for n dimensional way of analysis. Hence, they renamed that master tables into dimensions here, and the transaction table, it's a fact, right? Fact is nothing but a numerical value. Okay, so for example, our Kausik purchased in 2020 X product, two quantity, and this is a price. Okay, so it is a fact and it's a numerical value. Okay, team, that's why they renamed. At a high level, how you need to remember, in OLTP we used to call master table, for example, customer, product, branch, department, all those market, right, time. These are all master tables. When you try to load, so those tables generally will become a dim date, dim product, dim country, right? Like that. For example, transaction tables, order, sales, accounts, right? Finance, all that is nothing, expenses. These are all comes under the fact tables. Okay. So here we call it the dimensions and fact tables. Any doubt on this thing? Okay. No doubt, or you do not understand? Kausik, you got?
Sorry.
Yeah.
This
Yeah.
fact meaning, like when you mention that data warehouse is non-volatile, does
Ah,
that mean the
yeah,
same thing?
exactly. It's a history. Generally, we don't do any updations and deletions after loading Nabi. So we only query, meaning that it's a fact. It's happened.
Okay, so so for example, you mentioned, right, that in the OLTP, the transaction somebody ordered and then it got cancelled. They cancelled it later. So in the data warehouse, only the ordered part will be there.
No, yeah. Generally, we are extracting data during night time. By that time, I mean, say maybe 1 or 2 days time after that, we are extracting, right? So by the time, everything might be happen actually. So that's what I told you. If you remember my definition, the probability of changing the data is very rare. I mean, say only 5% of probability there is a change actually. 95% it won't change, especially the master data.
Okay.
Especially the master. At least transaction here and there, 1 or 2 can go and change, but very rare actually.
Okay.
Probability is there. That's why I'm telling Nabi. There is a 5% probability, there is a change, but 95% not much. And especially we don't delete actually.
Okay.
So this is a star schema, very, very important. So in OLTP, we go for more normalized one table into B. So if you recollect my second or third class, we made that big table into what? Employee, Kausik, DEPT and branch. One table we made into 3 or 4 tables, if you remember. So now if you want to query, you need to join 3-4 tables there, right? But when you try to load the data from OLTP to OLAP or data warehouse side, we might minimize the number of tables. Maybe we might combine 2-3 tables, single table, even though it is a redundancy, we try to load. Reason is we want every master table, dimension table directly linked with the fact table. For example, I will tell you one real-time scenario. It is a category, that's a one level, then subcategory, one more table, category, subcategory is linked. Then subcategory to product, and product table is directly linked with the fact table. So very lengthy, right? Category, subcategory, product, and the fact, which is a 4 layers of linking, 4 tables you want to join. So when you go for data warehouse, you join that product, subcategory, category, make it as a single table. Okay. So now it's going to be dim product, wherein you will have both category, subcategory information also in the product table itself. You are denormalized. So to directly link this product table with the fact table, I mean say for an orders table, right? So the reason is if you have more joins, obviously the performance will be go down, right? So nowadays storage is not a big challenge. We go and design this approach. So what is star schema? In star schema, the fact table or dimension table, all the dimension tables are directly linked with the fact table. In star schema, I'll repeat this, they will ask in interview also. In star schema, all the dimensions are directly linked with the fact table directly. So you'll have a, for example, if you see product ID, customer ID, region ID, year ID, right? All directly it will have a link directly. So that type of schema we are calling as a star schema. In star schema, all the dimension table are directly linked with the fact table. There is one more is a, so what will contain fact table? Fact table contain the primary keys of your dimension table. For example, product ID, account code, day code, right? All these product ID, customer ID, right? And branch ID, all those plus numeric values. Numeric values means facts. That's what we used to call. So units sold, quantity, revenue, and property. For example, order amount or a price or product price, all the numeric values plus your primary keys, product ID, employee key, customer ID, all those. So fact table contains the primary keys of your dimension tables and numeric values are facts actually. Okay. For example, order amount, order quantity, right? Profit. So those are all nothing but facts. So dimension table is nothing but a master tables. For example, dim product, what will contain, product ID, product name, size, price, all those you'll have. Okay. There are different the models. That's what we already discovered. Star schema. In star schema, this is a fact table and all these dimension tables are directly linked. Now coming to the snowflake, let's take this is a fact table. This fact table is a, let's take this is a dim product. Now dim product is connected with a dim category. So here in in snowflake, for example, if you look at this dimension, it is not directly linked with this fact table. It's a via. Snow means, you know, flake, right? Curve, little curve, meaning that, so in snowflake schema, all the dimensions are not directly linked with the fact table. It linked via some other dimension. So that type of schema we call as a snowflake schema. Now this is a multi-star, meaning that you will have multiple fact tables. Let's take it's a fact internet sales, it's a fact reseller sales. So, but a few dimensions are shared. For example, this dimension is linked with this fact table one. Same dimension is linked with this table as well. For example, dim product is linked with the internet sales. Dim product is linked with a reseller. Reseller means shops actually, right? So that type of dimension we call as a multi-star. Right? You will see different triangle love story movies, something like that. Okay, so yeah, that's what multi-star schema. Okay, so this is not required. Yeah, so we'll come back. Yeah, somebody's having doubt, please.
Yeah, Nabi. how do you decide which model you want to use or which model you want to be an expert on?
Yeah, generally we recommend star schema. Generally,
Okay.
for example, if your dimension master table is very big, now let's take one of the real time I worked on a shipment company. So the shipment is a master table, dimension table. But if a shipment and there is a 2-3 tables linked actually, if I try to keep in a star schema, it is taking so much memory. So I split at the time I went for Snowflake because shipment and the voyage is a route actually. Okay, so I made two and their pricing and all shipment details. So 3 tables. At the time I went for only one scenario, we went for Snowflake, but in all other scenarios I went for star only.
Okay.
Maybe.
If it's a if the table if the dim master table is huge, then you try to it's like kind of break
down into multi and try to join the fact table if it is a need.
Okay.
Very rare combination. But in data warehouse, we generally recommend to go for star schema.
Okay.
Okay, Tim. So